Perfect. It's 3 p.m. We can start. But first, I'll tell you a story, a small story. It's my favorite kind of stories. It's a story about myself. Vanity. So I started making presentation many years ago. In the very beginning, it was very simple, like just logo, plan, presentation. Then I decided that probably it makes sense to add a bit about myself so people could ask questions which are, let's say, which make sense. Because probably if you see what this person has been doing, you could ask more meaningful questions. So that was a second stage of me making presentations. Then after a while, some people started to tell me, Valerie, it's too much about yourself. You need to stop that. Everybody knows you. Well, back in Russia, probably not here. And then I decided to remove this information about myself. Time passed, and we recorded a couple of videos on YouTube about machine learning system design interviews, about system design interviews. So it was like a mock interview for an hour. There is a person, there is me, and we tried to walk through this interview. It was quite successful, tens of thousands of views, but then some people started to comment, who the hell are you? To question these people. And then I decided again that I'll put a bit of information about myself. So you see the fifth stage of me making a presentation with about myself, about me slide. So why I'm doing that, just to give you context about what have I done in my life. Well, the things I can share, of course, and what it makes sense to ask me about. Because probably after this talk, we'll have some time and hopefully you will have some answers. Of course, I expect my presentation to be so comprehensive that it will leave no space for any questions, but might be, it's not yet an ideal presentation. So right now, I work in a blockchain.com as a head of data science. As you can understand based on the name, it's quite an old crypto company. Well, because the blockchain.com is a fancy domain name. And this company was created in 2011. I mean, you're pretty young, try to remember what were you doing in 2011. It's probably not anything with a blockchain cryptocurrency. Before that, I was in a company formerly known as Facebook. Now it has another name. And now, well, I don't know, how would I say that? I'm a former meta mate, they call it that. Also, probably can't go back to Russia because just 2 days ago, it's been claimed an extremist organization in Russia. Yes, so I was a former member of extremist organization. And before that, I was working in some companies about which you probably have heard, like Alibaba. I was VP of machine learning. Unfortunately, not the whole Alibaba, just Alibaba Russia. Otherwise, it would be very hard to leave. But that is, you can see it's a mixture of engineering experience, like in Facebook, and management experience. So you guys are computer science students, right? Okay, that's good. How many, and you are part of Google Developer Student Club? Okay, so how many of you know what Causal is? Okay, not many. Okay, so the Causal is a platform bought by Google 3 or 4 years ago, the machine learning competition, etc., etc. And it's like a drug. So you start, it's like a gambling. You start to, have you participated in Causal? So do you have the same experience like it's a gamble? No, you're very lucky. Because I was doing that in my life as well. And I was participating in machine learning competitions. I achieved some good ranking. So if you'd like to discuss, machine learning is actually my field. Like I know a bit about data engineering, etc., but that's not it. So here's the plan. So you see it's the fifth stage. Sixth stage will be again without any information about myself, because maybe after this talk, you will give me a feedback like, Valerie, it was a terrible part about yourself, so you need to skip that. And then a new chapter in my life will begin. So it's oh, you see this. Let's remove that. At least I don't want to look at myself on the screen. I don't know, maybe you won't, but you have me in reality, and then there it's too much. So the plan is very simple. Blockchain is technology, blockchain is company, applied machine learning. I'll try to make it concise, succinct, and then try to answer questions if you have any. So let's start from blockchain technology, very brief overview. First of all, I'll do a very brief overview. If you are interested, well, there are abundance of materials on the web. You can go to this link. It is, how you pronounce his name, Andrews Horowitz School. And most pictures in this section taken from Chris Dixon and Dan Bond lectures. You can go to, you can use this link, go there, you'll find 1 hour lecture of Dan, 30 minutes lecture of Chris. They're much better in that than I am. But anyway, so a blockchain is actually a virtual computer that runs on top of a network of physical computers that provide strong, auditable, game-theoretic guarantees that the code it runs will continue to operate as designed. That's it. So that's a whole blockchain. You don't need to know anything about that. And here you can see like a scheme of that. We have a node, which like a physical computer, the blockchain runs on top of. You have the most important thing, which is a consensus mechanism. And then you have memory in terms of blocks and processors in terms of virtual machines. And that's it. So it's basically, you have your computer. So what you could say, what's the fuss about that? The thing is that companies like Google, Amazon, Bank of America, they all have lots of servers. Probably not surprised. And you guys know what the CAP theorem or CAP theorem, right? Consistency, availability, partition tolerance. Okay. At least some of you know. And you probably know that these companies, they have tons of servers. They need to ensure that state is consistent across all servers. So for example, probably if you're Bank of America, you need a thing called strong consistency, right? But because you work in financial data, transactional data, etc. If you have Facebook or Google, eventual consistency is okay. And this is not a new problem. If we have a known number of servers and all of them are authorized, this is very easy to solve. However, might be a thing which is like a new thing, new aspect, open consensus. So let's say we would like anyone to have opportunity to write new data to the, let's say, blockchain. There is no authentication. And of course, number of servers is unknown, right? Because you could switch your lab, you just download Bitcoin blockchain and start to mine. There is no authorization and you know. And this was shown to be impossible to guarantee consensus in many papers. But in 2008, a guy with the surname of Nakamoto found a way to bypass the lower bound using proof of work. And why is that important? Because let's say, so let's give you an example. Let's say do you guys have a thing which is called like a president of the class or president of the faculty or something like that? Okay, no election here, good. But you know what election is, right? Let's say president election in United States. And so let's imagine what stops me from coming to elections, apart from not being a US citizen, to go there and to pretend that I'm 1,000 people or 1,000,000 people or 1,000,000,000 people, I will vote for whoever I want, right? So let's say I pretend to be not a one person, but a 1,000,000,000 person. So now whoever I want to vote for is a winner, right? Because we have 300 million people in the United States, 350. I represent 1,000,000,000 people. Probably they could find that elections are rigged, but who knows? So, and this is known as a Sybil attack problem. So we might have 3 persons, and let's say we have a lottery in which we just need to roll a dice. And let's say everybody has a number. If this number is on the die, this person will win. Now imagine I say, actually I represent 1,000 people, so I have 1,000 numbers. So probably the probability of me winning competition is not 1 out of 3 as it was before, but 1,000 divided by 1,002. So is that a clear example? Let's say if I can pretend I'm more than one person, I can receive rewards for more than one person. So, and how to avoid that? So actually, this is the reason why Bitcoin is criticized. So you know why Bitcoin is criticized? For like consumption of energy, right? So it's one of the pain points that a lot of energy is wasted. So why people who mine Bitcoin do that? Well, they do that because there's a proof of work. This is how you can achieve the consensus if you have unknown number of servers and you have no authorization. Now, to prove that you represent as many entities as you say you are representing, you need to prove that. So what do these people do? They try to, let's say, provide a number of mathematical operations, and whoever is the first gets the reward. And this is proportional to the amount of work you invested. So pretty clear. You can't pretend you're 1,000 entities until you can work as 1,000 entities. If you can do that, that's more or less okay to have a reward. Well, the problem is it's very slow and wastes a lot of energy. And there are other different protocols, like proof of stake, for example. The problem is that proof of work for now is, let's say, most reliable. There are many ways how you still can try to break the proof of stake, which is basically how much cryptocurrency money you have. And for example, I just looked at that old article from 2018, and people said there that in next month, Ethereum will go to proof of stake. And you could find the same information in the article from a month ago. In the next month, the Ethereum will go to the proof of stake. I don't know if you guys have heard about this proof of space, but maybe you've heard a year ago, something like that. There was an outcry for a while that soon we'll have no SSD hard drives because miners in China will buy them all. Have you heard this kind of stuff? There's the same thing. It's proof of space. So you don't need to spend energy. You don't need to spend time. Just prove that you have enough space. But basically, you have the same idea behind all of that to prove that you are who you pretend to be. There are many, many more ideas about that. So, but the result of that is trust guarantees. The game theory of nodes plus consensus mechanism provides trust guarantees to anyone using it. Users, developers, creators, businesses, other computers or services, and no previous computer architecture could provide that. So because you can't just go and say, now guys, I'm a new entity here, I don't need to go through authorization, et cetera, et cetera, et cetera. No. And these trust guarantees means that the rules of the system can't change without due process as defined by the system governance protocols. So, and don't be evil, like a Google motto, becomes can't be evil. And these trust guarantees also enable the credible creation of new computing primitives. Digital money, digital goods, smart contracts, decentralized organization, etc. So basically, if you have very, very simple primitives, but you can guarantee them, you can build whatever. Let's say in our society, if we would assume that most of the people are malevolent and we can't trust them, probably will be no society. It's very hard to build something upon that. So by definition, probably we assume that most of the people are benevolent, they're good people, we can trust them, etc., etc., etc. So, but now imagine you don't have to trust, you have a guarantee. And another thing to review a blockchain is like the cake, it's different layers. Consensus layer is the main thing. If you have it, then you can build your cake. Then upon that, there is compute layer, which is a blockchain computer. And there are different blockchain computers. So how much do you know the difference between Ethereum and Bitcoin? I'll tell you. There is application level and user interface level. So it's like basic thing. So again, about the consensus layer, because it's the most important thing. There are different qualities it has to provide. A public data structure, ledger, it has to provide persistence. Once added, data can never be removed. Well, consensus, all honest participants have the same data. Liveness, honest participants can add new transactions. And openness, which is somewhat under the question because theoretically you can't create your own private blockchain with a password, etc. But anyone can be a participant, no authentication. So the blockchain computer, Application logic is encoded in a program that runs on blockchain. Rules are enforced by a public program, public source code. Well, transparency, there is no single trusted third party. And the app program is executed by parties who create new blocks. That's called mining. And there is public verifiability. Anyone can verify state transactions. So everything is open. Some people think that Bitcoin is an anonymous thing. It is not. It is a completely open thing. You can see everything there by design. And that leads us to execution environment. So let's say we have a Bitcoin script which runs upon the Bitcoin blockchain, a blockchain of Bitcoin. It's a very limited computing environment. There is a limited number of instructions, no loops, for example. You know that it's very hard to program anything without no loops. But it's sufficient for some tasks like atomic swaps, payment channels, well, how it's used. So that's why another analogy of the Bitcoin, it's like it's gold. Ethereum, and why it was a thing, it became a thing, is a general programming environment. Its environment is general purpose computing environment, so you can code anything on Ethereum. For example, a thing called smart contract. And application code updates internal state in response to transactions. And calling this application costs fees, gas. Why? Because then you call an application actually writing to blockchain is very expensive, because as soon as you write to blockchain, you know what's happening. Imagine you have 100,000 machines in Ethereum blockchain. As soon as your application is called, that means that each one of them will start to calculate or perform this application of yours. And only one will receive a reward. Actually, not one, but let's not go there, because there is like a thing called uncle in Ethereum blockchain, if you know what is that, so, but it's a different thing. So apparently it would be very easy to hack, to DDoS this blockchain, right? Just if every time I call an application, it runs on 100,000 machines, how could I just take it down? Well, I will just write while true, calculate something, and that's it. So job is done. So that's why you have to pay for that a fee, which is called gas. This is why you need Ethereum. So that's a biggest difference between the Bitcoin and Ethereum. So in a sense, that's why Ethereum might be reviewed as an oil. So while gold is a store of value, oil, you actually need to do different stuff. You need oil to have a gasoline, fuel, plastics, and all the rest. Rubber, probably, I don't know, is rubber made from oil? But a lot of things made from oil, many things. And well, when you have a decentralized, but one thing is that it's very constant to write to blockchain, very constant. So that's why a good app writes to blockchain in very limited fashion, only then it needs to do that. For any reason, like for example, if you have a smart contract, that's fine if you need to run an Ethereum blockchain, but you probably don't want to have your whole application calling the Ethereum blockchain. Otherwise, it's too expensive. Then you have an applications upon it. Well, you have a consensus, you have a compute-led. I mean, you're a computer scientist student. That's it. You have your computer, do whatever you want to do. You can create a game if you need a blockchain for that. And well, there are many things done using that, from payments, custodial services, investing, marketplaces. Well, you see that a lot of stuff. Like it's another question: do they really need blockchain? We wouldn't ask this question right now, but they do use. Some of them might need that. I think that you know some of these icons, right? Like probably Facebook, maybe I know Snap, but this was a situation 15 years ago for social networks. If you think about that, how it looks like, how it looks like now, it looks like that. Like you have YouTube, you have Twitter, Instagram, Facebook, Snap, LinkedIn, and that's basically it. So on most of the website, you'll see only these 6 or 3. Very similar to what we have right now in, like, say, cryptocurrency. Because, well, cryptocurrency is just one of the ways to use that. You actually don't need to use the cryptocurrency. The cryptocurrency sometimes is just a way to run the distributed computer, and then people who let's say provide their computing power for you to run this computer, they need to receive some reward. So that's it. So basically paying them for computing power. Now that was a very brief overview of blockchain as technology. Probably created more questions than answers, but probably that's a reason for every presentation, right? It's very hard to give answers in a short amount of time, but it's very easy to give right questions to ask. The blockchain as a company, sometimes confusing, because when I interview some people to blockchain and ask them what do we do, and ask, do you know what blockchain is doing? They usually very confused and are starting to describe, they are trying to describe technology, which I'm not asking them to do. So probably you guys have heard a company called Coinbase, right? Okay. So in early 2012, Reeves and Brian Armstrong, the co-founder of cryptocurrency exchange Coinbase, applied to Y Combinator's summer class 10 years ago. They proposed a payment platform for Bitcoin where users could keep a digital wallet, exchange other currency for Bitcoins for a percentage fee, and make payments in Bitcoin. Coinbase. Due to different opinions, they parted ways prior to attending Y Combinator. Reeves wanted to create a platform where users controlled access to their Bitcoin information, while Armstrong felt that the platform should retain custody of the users' wallets. And while Reeves continued to work on blockchain, that time Info, now Com, and Armstrong continued to work on Coinbase. And the biggest difference between those two approaches was the wallet, custodial or non-custodial. Do you know what's the difference between a custodial wallet and non-custodial? Okay, so you know, right? I remember. I was just to ask the question. Okay, yeah, you know what is the difference. No, I'm not asking you to explain the difference. I'm asking, do you know the difference? It's a very, very thin difference between that. Okay, so I have a bank card. Probably all of you have. I hope you're not making a photo of my numbers and 3 digits. I need to keep it. Just so who knows, probably the cameras and the modern days phone is good enough. But I trust you, right? Like I said, we need to trust each other. So this is my card. So trust. Well, I have some money, believe it or not, on this, no, not on this card. This card is just representation of the account I have in the bank. But actually, I don't own this money because every second the bank can just suspend my account for whatever reason. We saw some suspicious activity in your account. We have suspended it. Or maybe not that severe, but they could say, we don't do any business with Binance. It happened like a year ago. Like, now the question is it my money or your money? If you tell me I can't spend them for any kind of operation I'd like to do with Binance, or you could freeze them anytime. So that means that money in the custody of the bank, right? Well, probably if I have cash, those are my money. I have a custody upon them, probably. But again, maybe next second the government will tell, you know what? We have a new currency now. This money is not. Hopefully it will not happen, and that's why cash is more robust, but it's not very convenient. But in the world of blockchain, like we said, what we have this distributed computer, and we don't have any third party which has to verify or provide a service, meaning that actually we really can have a custody of our own money. If we want to send them to whoever we want to send them, there is nothing which can stop us. So that's the difference. And so let's say if you go to Coinbase and you deposit some money in Coinbase. So now this money, whatever it is, Bitcoin or GBP or whatever, in the custody of Coinbase. So anytime Coinbase can suspend it. If you go, but there are other type of wallets, non-custodial wallets, where nobody except for you have an access to the money. Well, it has a downside. So because if you take a look at the blockchain.com Twitter and you go to any tweet and you read the comments, literally the first comment would be, I lost control to my funds, blockchain, please help me. And we can't, because this is like disadvantage of non-custodial wallet. We don't have access, we don't have key, we have nothing. So, well, that's, you see the reason, but we can't block your money. So that was the difference in these two, let's say, opinions. And so blockchain originally started as a wallet. It was wallet for many, many years, non-custodial wallet. Then it also became an exchange. It also provided an information on-chain analysis. Like I said, most of the blockchains, they are open, meaning that you can see all the history, etc. Explore, trading, venture, and whatever. So, and basically, if you take a look into what the blockchain as a company is doing, it's not a breakthrough. People were doing that 100 years ago, right? So the only difference is that it's like a very different asset. So it's not a money, it's not a stock, it's a cryptocurrency. And also there is a thing which never has been done before, like non-custodial wallet. But in a nutshell, that's it. Okay, let's go to applied machine learning. Looks like we have time. So not that much here because I preferred to talk about that. And I was too lazy to make fancy slides, apart from the first two slides about myself, obviously, which is easy to transfer between presentations. So as soon as you're working with money, you're starting to work with the fraudulent transactions. What does it mean? Let's say someone will steal my card. So if this person is very desperate, this person will go to the Waitrose and buy some food. I mean, very desperate person. I mean, if you stole someone's card, it's probably not the thing you'd like to do. And remember, I'm telling you this, knowing that you already might have my card number and all the secret information. I trust you a lot. But what you can do, you can go to blockchain.com, take my card and buy Bitcoin, right? Then transfer it to non-custodial wallet and be happy because nobody can block you. You have a Bitcoin, you're very happy. Sounds like a good deal, right? So I gave you an idea. And that's why every time there is a transaction, every time when, oh, no, it's different presentation. Gosh. Well, actually, the difference is just in one slide because a very lazy person, I would think I can use one universal slide. I will just jump between this and that once in a while, but my dreams are broken. Okay, so every time there is a person who tries to buy a Bitcoin or Ethereum or whatever with a fiat currency, you know what fiat currency is? So this basically, it's a normal way of currency. It's like pounds, dollars, euros, whatever, it's a fiat currency. So every time then there is someone who's trying to buy a cryptocurrency with a fiat currency, we entering the realm of the government, right? Because this money, this fiat currency has been issued by the government. And not only government, but also the payment system, because to send some money, fiat money, you still have to use some centralized entity, Visa, MasterCard, or Union Pay. WeChat. I don't know if you use this, but I was working at Alibaba or using the many different things. And that means that this entity might come and tell us, look, guys, something is wrong here. You had too many fraudulent transactions. We're cutting you. No more payments through us. So meaning that, unfortunately, we still need to receive some fiat money as a company. And that's why we need to keep our fraudulent ratio or fraudulent transactions to legit transactions on some decent level. That's why every time a person is trying to buy something on the blockchain.com, there is a real-time machine learning system which tries to tell us if this transaction should be accepted or rejected. Well, it might sound easy, but actually every time when you guys have to work with the real time, something real time, it's a pain. Have you had a course on the distributed systems of parallel computing? How was it? Not good? Good? Good, but was it easy?
It wasn't easy.
It wasn't easy. I mean, yeah, it's never easy. So, and for example, back in my Facebook days, we have to handle like tens of millions queries per second. In blockchains, not yet that many. Unfortunately, we would like to handle tens of millions payments per second, but probably nobody is doing that. I mean, but still, it has to be in real time. It has to output some score between 0 and 1. And this score has to be a probability, because as soon as you have a probability of this transaction being fraudulent, you can multiply it by the amount of money in transaction. And now you can receive an expected amount of fraud for this transaction. And then you can make a decision. So that's what we're doing. And a bit of history about this in blockchain. I started in blockchain 4 months ago, so pretty fresh. The team size of data science, which is a terrible name, by the way, I'll tell you why, if you'd like to later, because the only thing which is more terrible than the job title head of data science is the job title data scientist. It's the worst thing in the world. I can prove it. So I started 4 months ago, and that time we had 3 people on the team. So now we have 30 people on the team. By the way, we're hiring. So if you'd like to, tell me. Internship, full-time employment, not only in the data science, but I haven't yet told you what data science is, right? Maybe it's something very cool. So what is data science in blockchain? It is data engineering and data infrastructure. It's machine learning engineering and machine learning infrastructure. It is, well, I lost the battle with the people in my department because I was trying to get rid of job title data scientist and have a job title machine learning engineer and a job title ML ops engineer. I failed. We don't have an ML ops engineer title, have machine learning engineer and data scientist. So machine learning infrastructure, modeling or data science, data analytics, and business intelligence visualization. So everything with the data. So before doing any kind of real-time fraud modeling, we had to do real-time infrastructure for real-time modeling. So, but that's the thing. As soon as you have infrastructure and you understand what you want to do, which is very rare, which is not the case most of the time. So most of the time when people do machine learning, they don't understand why they do that or what they want to achieve. Hard to believe, but it's true. But it's what we're doing. I mean, I told you too much, right? I told you that we don't understand what we're doing, but no, we understand what we're doing. We're doing a real-time fraud prediction in blockchain. Another thing is, as soon as we have someone on our platform, and this person hasn't yet started to buy any cryptocurrency, we need to understand who this person is if this person wants to make any transaction with fiat money. Again, for the same reason, because otherwise there might be money laundering or whatever. And we don't want to have that because the government will come and penalize us. We don't want to be penalized. And that's why every time a new person trying to register on a custodial wallet. There are custodial wallet and non-custodial wallet. You can still have your non-custodial wallet. You're like invincible, invisible, and free. Probably I had to have a Mel Gibson picture from the Braveheart Freedom. Is it prohibited in England to have this picture? Do you know? Do you know? Who knows? Maybe it's like a felony to show Mel Gibson crying freedom. Hopefully not. But anyway, anytime there is a person coming to blockchain trying to register, we need to understand a couple of things. A, this is a real person. Well, it helps a lot to understand if this person is real, because there is a high correlation between fake personality and fraudulent transaction. So for example, there is a person like Scrooge McDuck and you see there is like a fancy duck photo. It's probably not a real person. The second thing is that sometimes we have a marketing activities and we give a reward if someone will do something on the platform. Most frequently, something means to register. So that creates another opportunity for people. If I receive $10, just registering on the platform, the next move is apparent. I'll do that 1,000 times or 10,000 times. I mean, $10 times 10,000, not that. So that's why we need to understand that A, this person is real, B, this person hasn't registered on our platform already. So that's why a person has to provide an ID, we have to take a photo, and we have to understand if this ID has already been used, or it might be different ID. For example, I have two passports, the BRP, etc., right? So I can receive $30. I don't know how much it was to $30 to receive two passports in BRP, but still. Or maybe I could take a marker and just try to draw a fancy, how you call mustache? Mustache? How do you pronounce that? Mustache. Okay, and try to do that. So, and then a new person, right? New personality. One more time. Mustache? Mustache. Mustache. It's English language. Yeah, not easy. So yeah, I haven't tried. Give me $10. You see, my mustache helps me. They help me to do that, to achieve the financial independence. And that's why we need to take this photo to understand that it's the same photo or very similar to one we had before, and either reject in that case, or if it's like alleged person and new person, we need to accept that. And probably we need to do that fast. We need to do that quickly, because I don't think that someone will wait for a week. 10 minutes is okay, right? It's not real time, but still. Well, another thing is marketing. You see, I'm not saying you how we're solving that, because, well, I can't do that in an hour. I'm just saying you telling you what kind of problems we're trying to solve. Marketing is my favorite area. Very easy to fail here. So I'll give you an example. Let's say there is a person who is doing a marketing activity. I don't know how you call this person, marketing manager? Marketer? Head of marketing? Well, I don't want to offend head of marketing. No, just let's say in vacuum, just person who marketing manager. So let's say, let's say there was an activity. Let's say there was a discount, a promo code this person sent, and let's say out of 100 people, we received 10 people who decided to buy anything on the platform or whatever. Let's say they made an action we wanted them to make. So, and if this person is not very experienced, this person will come to us and tell, look, the efficiency of my marketing campaign is 10% because, well, 10 out of 100 done an action. But actually, if you started to think about that, probably without any campaign, maybe 8 out of 10 will do that, right? So now you see, okay, it would be 8, it became 10. Now you could say, okay, the efficiency is 25% because, well, 2 out of 8 is 25%. But if you start to think about that, let's say, oh, can I use this? I need, I can't say what I need because I forgot the word. How you say it? Marker? No? Marker. But there is another word for that. Crayon. Crayon is, okay. See, it's a both side education. You help me, I help you. It's very hard to express the feeling. Not being able to express yourself fully. It's very hard. Believe it or not, my Russian is much better than my English. Anyway, so now let's say the good and experienced marketing manager will tell that efficiency is 25%. But if you think about that, forget about it. I mean, I already failed with the slide. I can fail with the market.
No,
I'll leave. I'll leave. Look, I'll leave the town in 4 hours. It's okay. I will leave this shame behind me. But now, if you think about that, 8% or 8 out of 100, they receive the discount. But actually, they would buy this item without discount, right? By definition, because we know that without campaign 8 out of 10 will buy that, with campaign 10 out of 8. So now if you think about that, the efficiency of campaign is not 25% because campaign is not free. We lost some money on the people who would buy anyway. And we gain just on the people who wouldn't buy without the discount. So this is the cornerstone of marketing. How to find these people who wouldn't buy without discount, and how not to provide discount to the people who would buy anyway. Well, it's very easy to solve. We would have 2 parallel universes, right? In one universe, you send to everybody. In another universe, you send to nobody. And then you see who bought in the first universe, who bought in the second, and you just subtract. So solved. Unfortunately, we don't have a second universe. That's why we have to come with a field of causal inference, of causal statistics. You did have statistics, right?
Yeah.
Not very good statistics. Did you have a Bayesian statistics?
Yeah.
Okay, so classic statistics, Bayesian statistics, but no causal statistics, right? Okay. So there is a field of causal statistics which tries to, let's say, simulate the parallel universe and to tell us what would happen to this person if we will do that. Like imagine you have a crystal ball. So basically, and if you have an exam and you need to pick between 4 points and you have a crystal ball, apparently you will have a best mark ever because you just know what will happen if you'll pick these or these or these. So that's what we're trying to do in marketing. We have an hour, right? And we reserved 15 minutes for questions.
Yeah.
So probably I need to finish pretty soon.
It's okay.
Do you have a lunch? It's not okay. Okay, exchanger. So when people come to blockchain to make money on exchanging, we would like to know beforehand what would be the volume of their operations. Because, well, as exchanger, we need to provide this liquidity, so they would be able to make these operations. So basically what we're trying to do, we're trying to predict what would be the volume of operations for a week, for a month, and for a day ahead. Well, it's very easy to do that in the past, but unfortunately we need to predict what will be in the future. And that's what we're doing for exchanger. Another thing is the pricing. So pricing is, if you go to blockchain, you will find very interesting thing. You'll find that you can buy some stable coins. You know what stable coins are? So stable coins are very stable coins. Stable coins is a cryptocurrency connected to, let's say, the exchange ratio of the specific currency. Let's say there is a USDT which is like one USDT is $1. There is a, I don't know how you pronounce it, Celo, Cello, Euro, which is connected to Euro, etc. So if you go to blockchain, you'll find a very, very interesting thing, stunning, that you can put your stable coin in euros and receive 16% interest. Yeah, very strange thing, right? So why is that? Well, but did you ask yourself why you can go to the bank, like, let's say for Barclays or Revolut or Monzo, and put your money there and receive 1%? So because obviously these banks, they do something with your money, and probably they make more than 1% of that. Otherwise, it would be a bad business. So the same here, you can put your money, and then the trading team will start to trade this to make more money. So that's how it works. Now, the thing is, let's say we would like to attract some capital. We would like to attract some money. What will happen if we will provide not 16% on this euro, but 14 or 12 or 10 or 20? What is the right amount of reward? Maybe 8 will do that. And obviously 8 is much better for us. We need to pay less money, right? So that's another thing for pricing. And lending, well, lending is the most difficult thing, because people who try to make money out of buying and selling money, they need to be very cautious and very precise. And that's why they need to understand the movement of the market ahead of these movements. They need to predict them. But it's probably heard about the companies like Two Sigma, Citadel, what else? Renaissance, right? And there are many more companies like that in London, like Quadrature Capitals, etc., etc. So we're doing the same, but with the cryptocurrency, and apparently the volatility of crypto is much, much higher. Not as high as inflation in some countries, because, for example, recently we bought 2 companies in Argentina. And I have some people in my team from Argentina. What they told me that inflation is like 50–100% per year, every year. And they had to review their salary every 3 months, because otherwise there is inflation, there is no review of your salary, you're left behind. And that's why actually they prefer to use stable coins. So it's very crypto friendly country. And that's Argentina. It's pretty good there, because you can go to Venezuela and you can see tens of thousands% of inflation per year. So after that, if you tell, oh, Bitcoin is not stable, I mean, come on, go to Venezuela, you'll find out what is not stable there. That was a brief overview. I think we are right on time. And if you'd like to ask me anything or send your CV, there is a link to my LinkedIn account. Now I think we have some time to answer some questions. Maybe you'd like to know something in depth, or maybe whatever. So feel free to do that.
Anyone have any questions?
I see a hesitant hand.
No, the question, how old are you?
I am 31.
You look much older.
I look much older.
Okay.
And how did you start with crypto?
I'll give you, well, I'll tell you the story, okay? It's a long story, but we have time. Yeah, plenty of time.
Yeah.
So I was born in Russia, that time Soviet Union, very, very far away from Moscow. It actually was 4 times closer to Japan than to Moscow. It was like 1,000 miles from Japan, 4,000 miles from Moscow. Very, very north spot in Russia. Well, it is as north as you can see polar lights there. I mean, and -40 or sometimes -50 in the winter. Then my family moved to Russia, to Moscow, well, and to Russia because Soviet Union fell. Then I started in Moscow and I won a grant to study in Germany, and I studied in Germany. and I came back to Russia, and I started to work as a, let's say, chemical engineer in the company which was producing an equipment for analysis, food analysis, etc., etc. And they had two branches: chemical analysis and near-infrared spectroscopy analysis. And that was the time when first time I met a thing called machine learning. Because basically you have to emit infrared light and then see how it changed after it went through the sample and build the model based on these differences before and after what is inside this sample. So that's how I started to go deep into machine learning. I started to teach myself, self-learning, on Coursera, different books, attended different schools, and changed one company, another company, and became deeper and deeper into machine learning. Joined a company, grew the Department of Data Science from 5 people to 140. Yeah, I mean, I think that's now my primary skill, is just to create an unnecessary big data science department. Come to the company, tell us, you guys, you need 10 times more people. Hire these people, leave the company. Yeah, probably not. Don't have any plan to the blockchain. If you guys will be looking to this presentation, because there is recording. So anyway, long story short, I was very deep into machine learning, very, very deep into machine learning. But I spent all my life in Russia, except for this time I was in Germany. Russia is, well, let's say, if you go to the Facebook, for example, to Google, you'll find 3 largest groups in these companies. I mean, the people from different countries. So people from China, people from India, and people from Russia. For the first 2, it makes sense. Well, because there's like 1.5 billion people in China and 1.5 billion people in India. I mean, it's a very natural thing for them to have the largest group in any company, right? I mean, but it makes sense, right? If you take a look just. So, but the first group is people from Russia. Why? It's very good engineering culture. Not very good product culture, probably. So that's why I decided, okay, I need to move. And I received an offer to have a job interview in Facebook. And that's how I ended up in the Facebook. Facebook ended up to be an extremely boring place, like an extremely boring. But you see, this is like a difference between the big corporation and a startup. If you go to the large corporation, well-established, well-known, it has benefits. It's a well-established, well-known corporation, but it's very, very boring. And they hire extremely smart people to do extremely simple things. That's it. That's what they do. You have an extremely difficult hiring loop into the Facebook or Google. Once you're there, the job is extremely simple, like extremely, especially in Google. Google like is the best place for retirement. Facebook is not that good for retirement. We still have to do something in Facebook, but I can explain why. So I decided after 3 months in the Facebook, I decided I have to leave. But of course, if you join the Facebook, you receive the sign-on bonus, etc., you have to return that. I didn't want to do that. That's why I had to spend 9 months more in Facebook. So I decided, okay, what else? What shall I do? And then I've been contacted. Well, the question was, how did I start with crypto, right? It was. So actually, first time I started to work with crypto, it was in 2017. It was a Lithuanian-based startup called Moneta, and they were trying to do a mixture of PayPal and Amazon. And they had a very successful IPO. They raised like 200 million in USD, which is like 10% of the budget of the whole country they were living in. Not bad for company of 10 people. So they literally had more money in interest every year than they were spending. And they still exist. And I joined them as the principal data scientist to build some anti-fraud models, etc. But eventually they understood Yeah, that's my Slack channel. Probably someone wants to tell me something. Maybe they see, they're watching this right
Can
now
answer
online. Maybe the question, maybe threats. Who knows? I don't want to find out because in the best case, I'll have to answer the question. In the worst case, I'll receive a threat and my moral will go down. So no point to open that. So that's how the first time I started to work with crypto, but there was like a brief 6 months experience because later these guys understood that probably Lithuania is a good country, but it's not the best market for a mixture of PayPal and Amazon, and they didn't want to go outside. And that's understandable. They had enough money for the rest of their life. So why not? And then I was in Facebook, I decided to move on. I just met the guy from blockchain. We talked a bit about the company and what they need to do. And I found that really interesting and cool. Especially, it turned to be very useful last couple of months. Then I had to move all the rest of my money from Russia here. It was very useful. Good company. It's very good to know nobody can block your wallet. Because, for example, I had some cards. I still have them, but they're not operating anymore because Visa and MasterCard told people in Russia, you know what? Screw you guys. We're going home. So all the cards which were issued by Visa or MasterCard in Russia don't work anymore. So much about custodial and non-custodial wallets. So that's how, but it's complicated story. It's not like it was a direct path. From the very beginning, I understand that crypto is my life. No, nothing like that. It's
Anyone have any questions?
oh.
So please, virtuality.
I can't. Can you speak a bit louder?
All right. So virtuality, they are technologies that involve industry. So do you see how a link is the blockchain areas?
Well, I think that the biggest challenge right now. I'm not speaking like specific technology, but let's speak about the biggest challenge. The biggest challenge actually lies here because this proof of work. Well, let's say without consensus, no blockchain. Forget about that. Done. Now we have a proof of work. The thing is how to replace proof of work with something less energy consuming, more efficient. And this lies in, I can't even tell that lies in cryptographic, but this is somewhere there. So we need to find out the way to operate with consensus, but not to consume gigawatts of energy every day for that. Other than that, and another thing, how to make these operations faster, because another thing is that running the application on every node in the blockchain might be not the best case, might be. So, but no specific technology, but just these specific problems. If they're solved, then it's a completely different thing. So imagine you don't need to, well, it probably would be the worst day in life of the NVIDIA. But just imagine that nobody needs a GPU anymore. Well, you still need some computing power, right? Because you need to run this application. But it's just a normal PC can do that, the usual laptop. You don't need the rack, the ASICs or whatever to have this proof of work. So if I were NVIDIA, I would try to sabotage all this research in the area of moving from proof of work. Obviously, it's hundreds of billions of dollars. Come on, I mean, you can see. Take a look at the NVIDIA stock before and after. So
38 is around $3,000.
yeah, I mean. So can you speak a bit louder? A lot of countries. It's very hard to predict the future. Very hard. If I could predict the future, I would just open my interactive broker account right now and become a billionaire. But let's try to think what we have as a fact. We understand that money, the fiat money, is power. You can do many things with that. And while you're in control of this, you're in control of many things. So, and apparently, government doesn't want to give up this power. Well, it's easy to give up this power if you didn't have it. Like, for example, if you're not in the United States with the dollar or UK with GBP, which is more or less like the world currency, but let's say you're El Salvador, you don't have this power, so it's very easy for you to give it up. But I don't think that big guys like UK, EU, United States, China, well, especially China, but no, let's say especially China. I think every country, every government doesn't want to do that. So that's an interesting thing to see. I think they'll try to harness this technology because it has many benefits, many benefits. Like there are rumors of this, how they call it, digital yuan, digital USD, digital whatever. But again, it's very hard to predict, especially given that people in government most probably do not understand what blockchain is. So it's very hard to predict the movement of the entity which doesn't understand the technology which entity is working with. So what we've seen already with an internet, like internet started, let's say, so I had my first internet connection in 1997, but until 2005, like internet wasn't a thing, right? And from 2005 to 2015, it grew exponentially. But it was like a Wild West. No regulations, nothing. As soon as government understood that there are money there, they started to regulate that. But there is always a lag between that. And the question is, how many things, what will be implemented within this time frame before government understands and tries to do something? And this I can't tell anything. So might be in 15 years, if you'd like to have a mortgage, you'll have to have a smart contract on Ethereum. It makes a lot of sense, right? So it's if you have this mortgage, you can't fake it, you can't forge it, and it's very easy to see if you paid or not, etc. But maybe not, because there are many people, many entities, many organizations who have their living on this mortgage business, like auditors, banks, etc. Stamp duty. So that's why it's very hard to predict. That's why might be so. The thing is, if we review the blockchain as technology, I think that the cryptocurrency, they're already an asset, they're already a commodity. So it's $3 trillion right now. I would be surprised if in 10 years it would be 30 trillion. Because, well, overall the asset market is like 500 trillion. So even 30, and I think in 10 years it will be more than 500 trillion. So it makes sense. Which cryptocurrency will rise? I don't know. Well, Bitcoin and Ethereum, they have a high chance of still being in play for a simple reason, like gold and oil. But another thing is that would this technology became a completely new way to do this stuff? It has a potential, but having a potential, there is no guarantee it will be a go-to thing in 10 years for many reasons. So it's as an asset for sure. And some things you can't block. Well, if you have it as an asset and you have non-custodial wallet, you see, it's already disrupted to some things, right? Like, for example, tens of thousands of people from Russia moved to Turkey recently to just to flee from, you could say, regime, or they just disagree with the current policy. And then 3 days later, Visa and MasterCard told them, guys, you know what? Your cards, they don't work outside of Russia. And you're outside of Russia. But fortunately, in Istanbul, you can find an ATM which will give you money, like the currency of Turkey, if you have USDT cryptocurrency. So it's already, I think people are using. So that's only facts I have. I don't have any kind of, let's say, reliable opinion on that.
So we're nearly there, that time, but I'm sure if you want to answer one more question before we wrap it up, in case you guys want to, after the session's over, you could come and ask Valerie more questions. But yeah, last question.
I believe it's really hard to take anything. What do you think is the best way to do our own research on this Bitcoin? And another question, do you think that crypto will replace the banks? And if that happens, Bitcoins, do you think
Okay, let's start. Let's say it depends on what is your goal. So let's say if you go to receive more money, to invest some money, then pick 1, 2, 3, invest and forget about that. Because like I said, it's 3 trillion market right now. Probably in 10 years, it will be 30 trillion market. So meaning that some currency will just become more valuable. And by definition, you can't have more Bitcoin than 21 million coins. So by definition, there can't be no inflation. But again, depends on the goal, right? So what kind of research? If you'd like to understand what is behind in terms of technology, just read the white paper of this cryptocurrency, the Bitcoin white paper, the Ethereum white paper. If you'd like to invest, so my strategy is very simple: invest in some Bitcoin and Ethereum and forget about it, like completely forget about it. Well, I know many people who like invested $10,000 or $20,000 like 5 years ago. Now it's like in terms of millions. No guarantee it will happen again. However, I've heard the same 4 years ago, then Bitcoin price was like 1,000. Like, no way Bitcoin will go from like 1,000 to 100,000 because it already went from $10 to 1,000. You see, and like it was 60,000. So it's very hard to predict in that sense. Now, another question about the banks. So you see, even with the internet and all the way we can consume information right now, there are still paper news and magazines, etc. They are much less widespread, but they're still in place. So I would say that to some extent, cryptocurrency already has taken some chunk from the banks, some chunk from the payment system. Will it completely replace it? Depends on the government, right? Because, well, if you need to buy a property and you can't buy the property without the money, and you can't use a cryptocurrency, you have to prove that this money came from original source, or the bank has to guarantee something, that's it, right? So if you still have something which people need, and you can force the rule that to do that, you need to go there, you'll go there. So, and I can't imagine a situation that government will tell us, like, guys, we give you some power from us. We just decided it's too heavy for us to carry that. Just take it. The only possible scenario I can see that happening is after some disaster, and government doesn't have enough power to do that, and saying, okay, guys, you do that. That are hard to predict. So it's already disrupted for a while. And especially here in UK, it's hard for us to see many things because, for example, in Latin America, in Venezuela, in Argentina, it's already replaced banks like by 70% because banks and economy there is like disaster. The same thing I see right now in Russia because, well, Visa pulled, MasterCard pulled, people still need to make payments. There is a replacement, right? In UK, in EU, in US, probably not. China and India, I don't know. China is very close market. India.
They've just recently announced that crypto is going to be treated like assets. So like they're treated on the same level of like gold or whatever. And then it's just used for trading. You can't really do anything with it.
Yeah, but you see, it depends. For example, let's say India tomorrow will tell you, no, guys, we replace all the banks with crypto. It will affect the world largely because you have like 1.5 billion people there, You have a huge economy. Like, what is is it the third largest economy? Fourth?
It is quite a large.
It's
economy.
quite large. It's like
Nigeria.
probably top 5, right? So I mean, of course, it will affect, because as soon as you have one major economy doing that, it will either other economies have to do that, or this economy will become a kind of offshore, a harbor for all these crypto operations. So
I think that wraps up the Q&A session itself, like formally. But if you want to stick around and ask some further questions, you may. But yeah, thank you so much for everyone who attended the game session before and the talk. You guys have been amazing. Thank you so very much. Clap your hands.